Hi everyone. In today's session, we shall discuss about buoyancy and metacentric height. At the end of this session, you will be able to perceive what do you mean by buoyancy and flotation and equilibrium of flotation and submerged bodies, metacenter and metacentric height. So now let us start our session with buoyancy and flotation. Whenever you immerse a body in a partially or in a fully in a liquid, the upward force tends to lift the body is said to be a buoyancy force. So here we shall term as the tendency of immersed body to be lifted up in the fluid due to upward opposite force to an action of gravity is known as buoyancy. And this upward force principle was given by Archimedes, and he states that whenever a body is immersed in a fluid, either wholly or partially, it is buoyant or lifted up by a force which is equal to the weight of the fluid displaced by the body. So now let us consider a submerged body in a water as shown in diagram. This is a water surface and let us be the submerged body. Okay, and the upward force or thrust force for the submerged body, let it be F1 and F2. So the buoyancy force or the Archimedes principle states that the weight of the body to be displaced. So total buoyancy force is the downward force minus upward force, that is F2 minus F1. Now we know that at the F position 2, the specific gravity into the height of the liquid and the immersed liquid, that is H1 plus H2. So gamma into H1 plus H2 into its surface area dA minus gamma 1 into gamma into H1 into dA. So the result will be H1 is common, so it will be cancelled. Gamma, which is nothing but specific weight, the specific weight of the liquid into H2 into area, so which is nothing but specific weight into volume. So buoyancy force is equal to weight of the volume of liquid displaced by the body, and this can also be determined with the help of difference between the weight of the body in air and in liquid. So that is, let us take W is weight of the body in air and weight of the liquid in body in liquid is WL. So buoyancy force can be taken as weight of the liquid in the air minus weight of the liquid, weight of the body in the liquid. So now we shall go with what is center of buoyancy and what are different conditions. Center of buoyancy is indicated as B. It is the point of application of force of buoyancy on the body is known as a center of buoyancy. So like center of gravity of a particle, will be having for immersed liquids center of buoyancy. So it is always the center of gravity of the volume of the liquid displaced. So the center of gravity is equal to the center of buoyancy. So like this we can see the graph in the diagram, water force. So C and B are equal in the same position. So types of equilibrium in floating bodies. So now we are taking any floating bodies. First condition is stable. Stable means whenever you have smaller displacement change in angular displacement due to external force, it changes its position. So if the body return back its to original position due to internal forces from smaller angular displacement by some external force, then it is said to be in stable equilibrium. Like you see, this is initially when now the center is new to new displacement. If it is replicated to its original position, then it is said to be stable equilibrium. And in unstable equilibrium, if it does not reach back to its original position, then it is said to be unstable. You can see this. And neutral equilibrium means if a body when a given smaller angular displacement occupies new position and remains at rest in this new position, then it is said to be neutral equilibrium. So this is regarding buoyancy and the types of conditions of floating bodies. Now we shall go with what is metacenter and metacentric height. So we know that the center of buoyancy is the point of application of force of buoyancy on which the body is known as center of buoyancy, and the metacentric, the point about which body in stable equilibrium start to oscillate whenever a smaller angular displacement is called as meta-center. Whenever in a stable equilibrium condition, whenever you given smaller angular displacement, if it tries to oscillate, then it is said to be meta-center. So center of gravity and center of buoyancy will be in general with respect to at same position. With respect to displacement, the center of buoyancy will be moving from new position that is called as B dash, let it be. So metacentric height is termed as GM. The distance between center of gravity of floating body and the metacenter is nothing but metacentric height. So if you start, it is the initial position center of gravity, and this is metacentric. If you give some angle twist, it will be moving. So the distance between this BM, this B center of buoyancy minus this acceleration due to gravity, center of buoyancy to the center of gravity. This is nothing but your GM. The distance between center of gravity of floating body and metacenter is got to be metacentric height. GM is equal to BM minus BG, where BM is the distance between metacenter and center of buoyancy, and BG is the distance between center of gravity to the center of buoyancy. Okay. It is also having three conditions. One is stable equilibrium, unstable, and neutral equilibrium. If the position of metacenter is above the center of gravity, then it is said to be stable. If the position of metacenter is below the center of gravity, then it is unstable. If the position of metacenter coincides with center of gravity, then it is neutral equilibrium. Now we can see in this diagram. So here Z, okay, the mass is above, M is metacenter is above center of gravity, so then it is stable. And here it is below the center of gravity, so it is unstable. So metacentric height can be determined with two methods. One is analytical method and the experimental method. So now let us consider a cross section like this, and AC is the original water line. Okay, and if you apply B center of buoyancy to the equilibrium position, whenever the vessel is tilted with some angle theta like this, okay, the center of buoyancy will be moving from new position, that is B dash, and the distance and the A and C will be also position to A dash and C dash is a water line. A C dash, A dash, C dash is the water new displaced position. So to find out the metacentric height, we know that consider a small cross section area of dA. Okay, let this the cross section of elementary area of x into theta, where the angle of theta. So therefore the volume can be written as x into theta into dA. So the upward force of the elementary is, we know that buoyancy force is weight of the displacement into volume. So specific weight of the liquid into volume, x into theta into dA. So in order to find out the total position, integrate this with respect to position. So x into gamma into x theta dA is equal to gamma theta x square dA. So this is nothing but moment of inertia, gamma theta into I. So we know that FB is equal to weight of the fluid displaced into specific weight. So gamma V Bm theta. On simplifying, we get it Bm metacentric height is moment of inertia by volume of the liquid. So that is Gm is equal to Bm minus Bg. So these are the sample short answers and essays. Define metacentric height. So now you can write the metacentric height is nothing but the distance between the center of gravity of floating bodies and the metacenter is called as metacentric height. And define buoyancy. You know that the upward force acting whenever you immerse in liquid, the upward force thrust force acting on the body is nothing but buoyancy. So now we have the conditions for metacentric. If the position of metacenter is above the center of gravity, then it is stable condition. If it is below it is unstable. And if it is a position is equal, then it is said to be neutral equilibrium. Okay. So difference between metacentric and buoyancy. So thank you.